Okay, this is the 2025 Higher Level Applied Maths Solutions, question 8. On Monday morning, the symptoms of a specific infection were detected in 5 students. On Tuesday morning, the symptoms were detected in an additional 12 students. A local doctor predicts that the increase in the number of new infections detected on a given day will be twice the increase in the number of new infections detected on the previous day. The doctor wishes to model this prediction as a difference equation so as to determine UN, the number of new infections detected on day n. So we've got to write down a difference equation to express UN plus 2, UN plus 1, and UN. N is positive or equal to 0, and n is an integer. So what we're told here is that the doctor predicts that the increase in the number of new infections detected on a given day would be twice the increase from the previous day. So that just means the increase on a particular day, UN plus 2, minus the previous day, that's UN plus 1, that's the increase on a particular day, is going to be equal to twice the increase on the previous day. Well, the previous day is just going to be UN plus 1 minus the previous day, which is UN. So this is our difference equation here. So what we've got to do is simplify this a little bit. So it's UN plus 2 minus UN plus 1 is equal to twice UN plus 1 minus twice UN. Or if we just bring everything over to the left-hand side, we've got UN plus 2 minus 3 UN plus 1s, and then plus 2 times UN is equal to 0. So this is our difference equation. Okay, in part 2 it says, is this homogeneous difference equation or an inhomogeneous difference equation? Explain your answer. So I've written this out. It's homogeneous difference equation since there is a 0 on the right hand side and only the terms UN plus 2, UN plus 1 and UN on the left hand side. If there was, for example, a 3 on the right hand side, then this would be a non-homogeneous. In other words, there would be a term in there that's not a UN or UN plus 1 or UN plus 2. Okay, next question then is solve the difference equation to find an expression for UN in terms of n. So our equation was UN plus 2 minus 3 times UN plus 1 plus 2 times UN equal to 0. So the first thing we're going to do is write down the characteristic equation, and this is a quadratic here, so it's going to be x squared minus 3x plus 2 is equal to 0. We've just got to solve this. So we've got an x here, a 2 here, a 1 here. It's going to be minus minus, so x is equal to 2 or 1. So our two roots are different, so that means the solution will be in the form UN is equal to L times alpha to the power of n plus m times beta to the power of n. So our alpha and beta are our roots. So that means in this particular case, our solution is UN is equal to L times 2 to the power of n plus m times 1 to the power of n. What we've got to do now is work out what L and m are. Now we were told that U0 is equal to 5 students. So we're just going to put that in. So we're going to say 5 is equal to L times 2 to the power of 0. Remember, n is 0 plus m times 1 to the power of 0. So that gives us our first equation. 5 is just equal to L plus m. So this is equation number 1. So if we take u is equal to, I think the second one was 12. So this is u1. So u1 is equal to 12. So we can say 12 is equal to L times 2 to the power of 1 plus m times 1 to the power of 1. This will give us our second equation. 12 is equal to 2L plus m. This is equation number 2. Now I'm just going to take equation number 1 and multiply it by minus 1. Bring it down here. So that'll give me, let's see, minus 5 is equal to minus L minus m. Just going to add these two. I'll have 7 here and I'll have L here, and this will cancel. So L is equal to 7. So if L is equal to 7, I'm just going to take, let's see, 2L plus M is equal to 12. This is equation number 2. And I'm just going to stick in L, so it's going to be 2 times 7 plus M is equal to 12. That just gives me 2 7s 14, and M is equal to minus 2. So that will give me my final solution then. UN is, well, we have a 7 for L, so it's 7 times 2 to the power of N, minus 2 is our M, so we got to put 1 in here, and that's the power of N. This is the solution to our difference equation. Okay, next question then. Calculate the total number of infections detected between Monday morning and Friday evening. So let's write down the days then. We have Monday, Tuesday, Wednesday, Thursday, and Friday. On Monday there were 5 infections. This is U0. On Tuesday there were 12. That's U1. So you got U2, U3 to work out, and U4. So U2 we've got to work out then. U2 is just going to be equal to 7 times 2 to the power of 2 minus 2 times 1 to the power of 2. That'll give us 26. So we can put 26 in here. U3 is same thing again. 7 times 2 to the power of 3 minus 2 times 1 to the power of 3. That'll give us 54. So we can put 54 in here. And then finally we got 7 times 2 to the power of 4 minus 2 times 1 to the power of 4. That'll give us 110. And that is it really, 110. The question is calculate the total number of infections. So we just got to add these up. So the total is just 207. That's the total number of infections detected between Monday morning and Friday evening. Okay, next one then, B1. The population growth in a certain region can be modeled by the following differential equation. dp dt is equal to t squared e to the power of t, where p is the population and t is the time measured in years. Using integration by parts or otherwise derive an expression for p of t, the population at any time t, given that p0 is equal to 2200. So let's start anyway. We have dp dt is equal to t squared e to the power of t. So I'm going to do this by parts. And integration by parts, by the way, is the integral of u dv is equal to uv minus the integral of v du. So we need to use the inlate rule first. In is inverse, L is log, A is algebra, T is trig, and E is exponential functions. So we have algebra here and we have our exponential function here. So it's in the right order already. So the first thing I'm going to do is just let u equal to t squared. So we're going to let u equal to t squared. That means du dt is equal to 2t, or du is equal to 2t dt. So if u is equal to t squared, I'm just going to let dv then equal to e to the power of t. So that just means if I integrate both sides, I'll get v here, and if you integrate e to the power of t, you'll just get e to the power of t. Okay, so we're just ready to do our substitutions in here, or to use the integration by parts rule here. So I want to integrate this here. So if I integrate the left hand side, I'll just get d of p. On the right hand side then I want to integrate t squared. I want to integrate t squared e to the power of t dt. So let's use our integration by parts rule. So the first thing we need to do is multiply u by v. So u is t squared and v is e to the power of t. So then we've got to subtract the integral of v du, So the integral of v, well, v is e to the power of t and du is 2t dt. That's it here. Okay, so let's just simplify this a little bit. So we've got t squared e to the power of t minus, I'm just going to take that 2 out here, the integral of e to the power of t times t dt. Okay, so it looks like we're going to have to go again here. We're going to have to use integration by parts again here. So we get t squared e to the power of t minus 2 times, now actually what I'm going to need to do here is just switch these around. I want to put t first and then e to the power of t here, dt. So let's use integration by parts again just to do the integral part of this. So it's t squared e to the power of t minus twice, and I want to just integrate this here. So I'm going to let u this time equal to t, so that means du is equal to dt. I'm going to let dv equal to e to the power of t dt. Integrate both sides, you get v is equal to e to the power of t. So let's substitute that in then. Well, we want u times v first. Well, that's t times e to the power of t. Then it's minus the integral of v du. So it's minus the integral of v du is dt. So that's fine so far. All we've got to do now is just simplify this. So it's t squared e to the power of t minus 2t e to the power of t. And if you integrate e to the power of t, you'll get e to the power of t. So this is just going to be minus minus, which is plus 2e to the power of t. And then we also need to stick in our constant of integration as well. Okay, so this is our p of t here. So what I'm going to do then is just maybe factorize out that e to the power of t. So p of t is equal to e to the power of t times t squared minus 2t plus 2 plus c. Now we were told in the question that P0 is 2200, so that just means that 2200 will be equal to e to the power of 0 times 0 squared minus 2 times 0 plus 2 plus c. That'll give us 2200 is equal to 1 times 0 to the power of 2 is 0, 2 times 0 is 0. We end up with a 2 there plus c. So we just subtract 2 from both sides and we get 2198 is equal to c. So our solution then is p of t is equal to e to the power of t times t squared minus 2t plus 2. And we work out our c as plus 2198. Okay, last question then. Calculate p of 5, the population after 5 years. So you just got to put our numbers in here. So p of 5 then is just equal to e to the power of 5, 5 squared minus 2 times 5 plus 2 plus 2198. When you do all of that, you get 4,721. Okay, that's it for this question.